Okay, so today I'm going to show you how to factor quadratics, also known as factoring trinomials, and I'm going to go through a few examples with this. Before we get started, I want to do a very quick review of the box method for multiplying two binomials together. And so if you recall, we're going to create a box to simplify these two sets of parentheses, where one of them is going to act as the length, so x minus 2 can be written up here, and the other can act as the width, x plus 9. And then we're going to find the area of each of these four sections to get the total area. So x times x is x squared, x times negative 2 is negative 2x, 9 times x is 9x, and 9 times negative 2 is negative 18. And when we add all of those together, we get x squared. I'll go ahead and combine my like terms here. 9x minus 2x is 7x minus 18. So what we're going to do with factoring is actually this entire process backwards. We're going to start with this quadratic or trinomial here. It's called a trinomial because there's three of them. And we're actually going to work backwards to figure out what the original length and width of the box is supposed to be. So here I have kind of a loose definition of factoring for what we're doing in this unit. We're going to be rewriting a trinomial like this one where a, b, and c are some sort of constant numbers or coefficients into something like two sets of parentheses like this, where p and q are some numbers there. So for this example, we have x squared plus 8x plus 15. I'm going to go ahead and draw my box. This box is going to be kind of like a puzzle that we're going to fill out. And I'm going to reference the previous example to kind of help us with this. And so if you notice, we have our x squared here. That's always going to be the top left of your box. So that's something that you can always fill out to start. X squared is going to go in the top left. And the other thing that's always going to be in there is the constant that's on the end is always going to be in the bottom right of the box. This diagonal here is going to be a little bit tricky for us. We'll have to do some guessing and checking, but we can start with what we have. So this constant on the end is going to go in the bottom right. And let's see if we can use this to begin to figure out what the length and the width of the box is supposed to be. So for our purposes, we are going to be having x by x in the top left and on the top of the box. And then we want to think about what numbers are going to multiply to give me this constant down here, 15. And it's not very clear what we're going to put in these diagonals quite yet, but we do know that they need to add up to 8x. If you notice, we did add these up. 9x plus negative 2x did give me 7x right here. And 7x is the middle term of our trinomial. And so I'm going to look at this 8x right here, which is the middle term, and I'm going to think of two numbers that add up to give me 8, and they need to also multiply to give me 15, because I need to think of a number over here and a number over here that multiplies to give me 15. And a pretty simple one is 3 times 5 is going to multiply to give you 15. Also, don't forget about 1 times 15 could be an option. So if I test those out, if I first test out 3 times 5, I'm going to get 3x here and 5x here, and that middle term here is going to add up to 8x. 3 plus 5 gives me 8. 3 times 5 gives me 15. And so what do we do with this? Well, we basically found the length and the width of the box. I should add some plus signs here, but basically my two sets of parentheses are going to be x plus 3, which is labeled as the left side of the box, times x plus 5. And this is the factored form of this trinomial right here. Let's do another example. We need to factor x squared plus 14x plus 24. I'm going to go ahead and draw my box. And we want to think about what can we already put in the box? What do we already know? Well, in the top left of the box, we can put our x squared. And in the bottom right, we can put this 24. And we also know that x times x is going to give me x squared. Now, we need to think of two numbers that are going to multiply to give me 24 and add to give me 14. Now, there's a lot of different numbers that multiply to 24, so I'm going to go ahead and list them out. So to make an exhaustive list of all the things that multiply to get to 24, I like to start with the number 1. So 1 times 24 gives me 24. And then we'll do 2 and 3 and 4 and 5 and see if those are going to multiply by something. 2 times 12 will give me 24. 3 times 8 gives me 24. And 4 times 6 gives me 24. Then 5 times nothing gives me 24 right away, but then we start to move backwards over to 6 times 4, and we don't need to repeat these because you can multiply in any order, and so this is really the exhaustive list we have. So one of these options is going to multiply to give me 24, but which of them is going to also add up to give me 14x when I have them in these diagonals here? We want to think of things that add to give me 14x, and that's going to be 2 and 12. 2 plus 12 gives me 14x. So I'm going to have 2 and 12 on either side here. Really, I'm just filling out the rest of the box to make sure things work out. 2x plus 12x is going to give me that 14x in the middle of the trinomial. And I really have my set of parentheses, if you will. I have x plus 2 and x plus 12. And the order that you write those in doesn't matter. You'll get it correct either way. Let's do one last example with negatives involved. So I have x squared minus 3x minus 10. Go ahead and draw my box here. And just like before, we're going to put what we already know into the box. We can put x squared in the top left. And don't forget that negative is attached to that 10 there. So I want to make sure I have negative 10 in the bottom right. That's going to affect the rest of the box that I'm trying to fill out here. We also know that this is going to be x by x. And then we want to figure out what two numbers are going to multiply to negative 10 and add to negative 3. Notice how we have a negative in front of it, which will make things a little different here. So my list gets a little more interesting. Few things that we can think of that multiply to give me 10. I have 1 times 10 and 2 times 5, but I actually need to list a few more examples there because I could multiply negative 1 times positive 10 to give me this negative, or it could be positive 1 times negative 10. When I add those together, that's going to give me a different answer when I combine them. And so there's also negative 2 times positive 5 and positive 2 times negative 5. My list basically doubles. And so I want to think about which of these are going to add to give me negative 3x. And that's going to be the last option there. 2 minus 5 gives us negative 3. You can fill out the rest of the box if it helps things feel complete. And let's write our two sets of parentheses here. I'm going to go ahead and add this. My width is x plus 2, and my length is x minus 5. I'm going to add a Khan Academy video to the end of this that's pretty short, just to see if you'll find that method a bit more useful than the box method here.